Salam everyone and welcome back. After covering the basics in our first three videos, we are jumping straight to exercise number 10. As the intermediate problems are quite straightforward, today we have an exciting challenge solving a three-variable system of linear equations with a special focus on finding the inverse matrix and the cofactor matrix. We will also use Cramer's rule to verify our results. Let's finish strong. We are given a system called S with three equations and variables x, y, and z. Our first step is to transform this system into the matrix equation Ax equals b. We write matrix A using the coefficients from our equations. Be careful with the third row since there is no y term, the coefficient is 0. We multiply this by our variable vector x and set it equal to our constants 5, 1, and 3. Here is b and the vector x and the matrix A. To use the inverse method, let's begin by finding the determinant of matrix A to ensure it is invertible. We will expand along the first row to find our minors. The determinant is minus 1. Since it is not 0, the inverse matrix exists. Next, we have to calculate the cofactor matrix. Let's take A and go to another page. We have to find the 2 by 2 minors for each position and apply our alternating signs. Now we have to calculate the small determinants. Minus 1, minus 2, 1, minus 1, minus 1, 1, 1, 3, and minus 2. Now we take the transpose. We only have to swap the rows and columns. Now to calculate the inverse matrix, we only have to divide by the determinant of A, which is minus 1. We only have to change the sign of each element. Now to solve the system, okay, we have to multiply our inverse matrix by the vector B. X equals to the inverse matrix multiplied by B, which is, I have to take the inverse matrix first, then I multiply it by our vector B. We have to do the arithmetic. 5 plus 1 minus 3, 10 plus 1 minus 9, and minus 5, minus 1, and 6. This gives us our result, which is 3, 2, and 0. To verify that the solution is correct, we only have to put it in our first system. Let's try it. For the first equation, we have this. For the second equation, we have 1, okay. And the third equation, we have the result. Then our vector is correct. To wrap things up, let's verify our solution using Cramer's method. I have to take the system and put it in a new page. Okay. To calculate the solution of our system, we have to calculate x, y, and z. First, we have to calculate the determinant of ax by the determinant of a. We only have to substitute the vector b inside matrix. Then we calculate the determinant. I need more space, which is minus 3 over minus 1, which is 3. We have to do the same thing for y and z. Now we calculate the determinant. And we do the same thing for z. Which is exactly 0. Then our solution of the system is the vector x given by 3, 2, and 0, and both methods gives us the same result. This brings us to the end of this exercise and to the end of our series on matrices and linear systems. I hope these step-by-step tutorials have helped you master these concepts. Keep practicing and good luck with your exams. Teaching such brilliant students has been a real pleasure. I am proud of your hard work and I wish for you the very best for the future.